All right, let's get started. So, first order of business here, a little in advance, but happy Thanksgiving. And those of you who ever had a husky or have been in contact with that breed, you know exactly what kind of drama is about to unfold there. IE4, still just a reminder, okay? It's already released. It's due tomorrow, so get rid of it before you go on your Thanksgiving holiday. Official course evaluation, again, I'm going to keep reminding you because this is really important. Okay, as a matter of fact, I'm going to share with you real quick. There we go. That's the wrong one. Okay. This is what I want to share with you, which is pretty much the view that I get of those things. So I want to show you the current response rates. Okay. So of course it's anonymous. What we see here is the current response rate. They are very low. Okay, so just showing you that to encourage you to participate. It's really important. Low response rate like that, you would think that they are interpreted in one way or the other. You know, like everything is okay or everything is awful. But no, they are not. They are just interpreted as, well, students really don't care what's happening in that course or something like that. That's one of the things that comes out of it, at least for me. Okay, so please make sure that you take the time. And I know that you are busy at the end of the semester. Trust me, it's a rush for everybody. So, but anyway, I wanted to show you that. What else? The final exam. Let's start talking about the final exam. So we have the date set. It's going to be Sunday, the 5th. It's going to be noon 30 to 2:30 p.m. The one thing that I'm still working on double checking right now is where. So I don't think we have a room assigned yet. We should get a room assigned very fast because our exam is about like a week and a half down the road. So it's about time to have a room here. I'm checking right now. I sent an email this morning to double check and make sure that we didn't get forgotten or something like that. As soon as I know, I'll probably post an announcement on Piazza. Okay, so stay tuned for that. Other than that, as far as what we control and what we can prepare for, the slide is just like a condensed overview of everything that we have studied this semester together, pretty much. Okay, the final exam is open book. You are going to be able to bring your book, digital or paper. You are going to be able to bring your laptop, and actually you'll have to bring your physical laptop, to campus to take the exam. You'll be able to access the slides, the PDF of the slide of the course. So it's your choice whether you want to print them out or whether you want to just access them through Canvas. It's okay. Anything else, not allowed. Okay. And the question that comes most often is, well, can I bring like a few examples of code that I've been working on during the semester or that I downloaded and I find particularly useful? And the answer to that, unfortunately, is no. Because when I allow that kind of stuff, I see students amass huge quantity of code and think that they can solve the exam by just, like going and finding a code that is similar enough. So no, I want you to be able to write code yourself independently from scratch. That's the goal for this course. That was the goal for COP2513 as well. So that's why we don't have like the Library of Congress in terms of code example available during the exam. Other than that, every topic that we covered, yes, it's going to be as a menu, including files that we are going to most likely finish today. One more thing before we jump into the fray. I sent out a poll yesterday, and I was surprised that already 8 people answered, actually, despite the fact that I sent it like relatively late at night. So I sent a quick poll yesterday regarding how we are going to organize our review week. So we have 2 options. One option is to do it traditional way. That means we come here to class, you bring your laptops, we do hands-on review session. So the 2 sessions after Thanksgiving are going to be entirely focused, if I can, on preparing for the final exam. I say if I can because if I need to just finish a little bit of lecturing on files, then I will have to take time to do that, okay? But as much as I can, I try to reserve that week for last minute preparation for the exam, final rush, okay? So the first way we can do it is here in class. The only constraint is that it's 1 hour 15 minutes. The final exam are 2 hours. I would like to put you through like a 2-hour session at least to prepare you for the final exam, okay? The second option is we do it online, and therefore I can stretch a little the 2-hour session. I can record them for those who cannot stay past the regular end of the course. Blah, blah, blah. You saw that already. These are the responses that I have right now. Okay? So I think it's 1 to 8 or something like that. So it's anonymous, again. That's the whole point. So I'm just showing you that so that you know that this is what's going on right now, and I will post updates. If you are okay with that result, that doesn't mean you should not vote. If you're not okay with that result, that definitely means you should vote, okay? I want to try to find something that is going to make at least, I cannot make everybody happy, but I try to find something that's going to make at least the majority of you happy. It would bother me a little if the vote is tight and it's only like one vote that makes the difference. That would be a little bit of a weird situation here. It's kind of a Kobayashi Maru. Everybody kind of is unhappy at the end. All right. All this being said, this is where we stopped last time. Last time we were dealing with exceptions. We covered pretty much like the basics of exception. So if you are writing a method that throws an exception, it's easy. You have to declare it. Okay, you have to declare that your method throws an exception, keyword throws, and you have to, at some point in the code of that method, detect the situation, so generally a if statement is going to tell you, hey, there is something fishy going on here, and now I can raise the exception using the keyword throw. So that was relatively painless, okay? Now, when you are using method, which unfortunately you use way more often methods that throw exception than you write yourself method that throw exception. So in the common case where you're just calling a method like you are going to see with the file IO, we are going to call methods that are likely to raise exception, and these are going to be checked exception. You have to ask yourself, what kind of exception can this method raise? If it's a checked exception, you have to act. Okay, the compiler will not let it go until you handle fully the exception. Handling fully the exception, we saw 3 strategies. One of them is catch it with a try-catch block, and inside the catch block, do everything you need to do to fix the problem. So that's the most common approach. The second one is declare the exception, which means you don't even try to catch it, okay, because you cannot do anything about it. So you just declare your own method as throwing the same kind of exception, meaning it's going to just bubble up, it's going to pass along. And then the hybrid strategy, which is actually you catch the exception. Maybe you are capable to do some processing, like logging to a log file or something like that, and then you rethrow the exception again with the keyword throw. And interesting bits that I've not been emphasizing so far, but we're going to see it in an example during the review week. You can rethrow the exception that you got from the method you called. But nothing prevents you from actually throwing a totally different exception. So for example, I can catch an IO exception, I can catch an illegal argument exception, but you know what? I'm not going to pass that up to whoever called me. I'm just going to pass up to them a custom exception that says, for example, problem with configuration file exception. And that means that I don't technically adhere to any one of those 3 strategies completely. I just follow the try, catch, and rethrow strategy, but instead of rethrowing just what I got, I throw a different exception. And it can be a custom exception, it could be like a pre-made exception. Java doesn't care. The choice of the exception class is entirely up to the programmer. It's a deal between the programmer and other programmers that are going to write code that's going to receive those exceptions. So as long as you document, you cannot go wrong. Last but not least, what if this method that you're calling is not throwing a checked exception? It's throwing an unchecked exception. Well, then everything goes. Okay? We've seen that. Some programmers are going to declare it. Some programmers are going to catch it, rethrow it, whatever. It doesn't matter. The compiler doesn't care. Of course, it matters to you. because that's going to change the behavior of your code. But as far as the compiler is concerned, you are not obligated to do anything. All right, and now what we're going to do is we're going to apply all this to a topic that is very, very ripe with actually exception handling. It's a topic of input-output. So there are different types of input-output, okay? We do input-output when we are pretty much connecting to a database. We do input-output when we are sending data over the network, over a socket. We do input-output also to files. And files is the one that's local, that's easy to test. So this is the one we're going to use as an example. In the realm of files, input-output, there are generally two types of files that are considered. The text files, which are just an accumulation of character, one after the other, with some special character that say, hey, this is the end of a line of text. So those special characters we're going to see vary from operating system to operating system. And then there are what we call sometimes the binary files or the records files that have like a very structured format. So each time you write and read to one of those files, you write and read in an entire structure, like a class, for example, a bunch of attributes together, and then you read that. You are going to do that probably in COP2513 when you study the C language. There is a struct keyword in C that pretty much allows you to have not the equivalent of a class, but at least a container with several attributes inside of it. And this is typically what we are going to read and write in those files. So what we are going to do today, we are going to focus on the text files, because one, they are like the simple one to use, and two, they are going to make a good illustration, and three, they are actually very, very convenient. Okay, once you know how to do some I/O on text file, as I'm going to try to show you at the end of the session, you can interact with web servers and stuff like that very, very easily. The textbook has a great example of a little web crawler that we are going to finish pretty much the session with. All right, so let's dig in. What do we have to say about files? So the first thing I want to do is make sure everybody's on the same page. So maybe some of this is going to be, or 90% of this is going to be already known to you. Bear with me. I want to make sure everybody knows all of the concepts that are on this slide. So I chose two operating systems to make the comparison, Windows and Linux. Nothing against Mac OS, it's just that Mac OS is actually based on a variant of Unix, and Linux is a variant of Unix. So instead of Linux, I could have put Unix-like operating system in the second column, and that would have gathered together Linux and Mac OS as well. So Windows on one side, the Unix family on the other side. Let's talk about a few things. When people talk about file name, me first, I generally talk about just the end of the file name, okay? Which is, for example, mydata.dat, okay? In the correct terminology when you say file name is actually the entire file name. The entire file name, the fully qualified file name, is what allows you to find the file on disk. So on Windows, you're used to it. It's going to be C:\\, some folder, some subfolder, some subfolder, etc., until you reach your file. So it's the entire, what we call also the path to reach the file, plus what is just the file name at the end. All of that is considered the file name. In Unix-like operating system, we have a first point of difference here. The first point of difference is that we use a slash instead of the backslash, okay? So you get used to that. Backslash for Windows, / for Linux and Unix. It's used the same way. The slash is, forward or backward, is actually the separator between the name of the folder and subfolders up to the basic file name at the end. So that basic file name, which is in our example C: users alessio readme.txt, which is the readme.txt part, is actually called the base name. If some of you have been using some command line on Linux or Unix, you are going to be using that when you do cybersecurity anyway. There is even a command in the Unix system called base name, quite appropriately, that allows you to take a string that represents a complete file name and will extract for you that base name that is just the name of the file without the path to access it. The rest, the part that is not the base name, so C:\, users, alessio, etc., this is going to be referred to as the path name. This is the location of the file. This is a folder in which your file is located. We already talked about the separator. Another thing that we need to talk about to differentiate Windows and the Unix family of operating system when it comes time to refer to files on disk is the concept of root. So both types of operating system have the notion of the root of a file system. The root of the file system is where the file system starts. Okay? There's nothing above the root. There are only subfolders, and those subfolders have themselves subfolders. So think of it like kind of the relation of inheritance. It's a hierarchy. It's a tree. Okay? The difference is how we note the root. In Linux and Unix operating system, we note the root of the file system as /. In Windows operating systems, we denote it with a letter, generally uppercase, followed by a colon, followed by a \. It goes a little beyond that. In Windows, the idea is that if you have 2 hard drives with 3 partitions each, you have a total of 6 independent file systems, and each of them is assigned a letter. So it's like saying in Windows you don't have a tree structure, you have a forest. You have multiple partitions that each have their letter assigned, and each letter has a tree under it, which is a file system for that partition, the file system that lives on that partition. In Unix operating systems, things are a little different. There is a unique root. There's only one root, which is /. So does that mean that we cannot have partition, multiple hard drive and stuff like that? Absolutely not. You can have multiple partitions. You can have multiple hard drive, and each of them is going to be formatted featuring its own file system. However, the way that you access all of your file system in Unix is somewhat unified in the sense that it all starts with /, and then under /, generally in a subfolder called MNT for mount, you are going to be able to access subfolders that represent entire partition. There is a saying in Unix that says that everything is a file. It's barely exaggerated. Okay? Like your hard drive partition, they appear like subfolders in the file system under /. Your device appear actually as special file that you can read and write to and from under also the / root of the file system. Okay? So it's a completely different philosophy of organizing things. At the end of the day, for what we are concerned about here right now, what matters is the difference in addressing a file. So in Windows, you have to know pretty much which partition it is on and use the letter that correspond. On Unix, you would start with /. Then you need to know where that specific partition has been mounted. That's the terminology when we take a partition and we connect it to a subfolder on the file system. Okay? And you would have, for example, /mnt /USB-A. That would be your thumb drive. Okay? All right. Next thing we need to talk about, the notion of absolute and relative path. So let's start with the absolute path. The absolute path is the one way to designate a specific file inside a file system. So it starts always at the root of the file system. Again, for Unix, that's /. No question. For Windows, that can be any of the letter drives, followed by colon, followed by \. The concept of absolute path means that you give direction to somebody to find your file starting at the beginning of the file system. In comparison to that, the concept of relative path means that you are going to give direction to somebody in order to find a file, but those directions are not going to start at the root of the file system. They are going to start in what is called your current working directory. Your current working directory, that means when you start an application, when you open up a command line interface in Windows or Unix or Linux or Mac OS, when you open your terminal, your application starts execution inside a specific folder on the file system. This is its current working directory. And then it can change that folder if it wants to, okay? But by default, if you just try to open a file, create a file, read a file, and you just specify the name of the file, it's going to be assumed that this is in reference to the current working directory. So readme.txt in both type of operating system, that means the readme.txt file that is located in my current working directory. It's most of use when you are opening a shell, okay, a terminal, a command line interface, and you are typing a command like dir on Windows or ls on the Unix system that just lists the content of your current working directory. It's going to show you pretty much where you are at in the file system. I am inside, for example, /home/user/alessio, and I can see this and this and this subfolders, this and this and this files available. With the concept of relative path comes two little notation, the dot and the dot, the double dot, okay? These can be included anywhere in a path name. And they have the following meaning. The dot just means the current directory. So for example, when I write readme.txt, this is exactly the same as dot/readme.txt, which you read as inside the current working directory / the file readme.txt, or dot /readme.txt, depending on whether you are on a Unix-like system or Windows. So that one sounds kind of useless. There is one case where it's important to name something by calling it readme.txt or dot/readme.txt. It's not going to be relevant for a readme.txt file, but it's going to be relevant for a script, for example, that you want to execute. Like, for example, if I want to execute a script named myscript.sh on a Linux system, and it's sitting right here in my current working directory under /home user alessio, for example, which one is best? Should I type myscript.sh to get it started, or dot/myscript.sh? The answer is almost always dot/myscript.sh for security reasons. There is, in every operating system, we have the concept of an environmental variable called path. So it's a variable that is defined pretty much at the operating system level, accessible via the command line. It's spelled PATH, all uppercase. The path is a list of folder where you are going to be likely to find things to run, executables, scripts, and stuff like that, okay? So when you type a command on your command line interface, ls is probably a bad example because, no, actually ls is not internal, so it's a good example. When you type ls, enter on your Linux terminal, okay? What happens? The shell is going to look through every one of those folders in order that are listed in the path variable, and it's going to look for ls executable. And the first one that is found, bingo, I'm going to use it. So when you type just the name of a command, the name of a script, you depend on how the variable path has been set. If somebody makes their own version of your command, name it the same way, put it in a hidden folder somewhere, and modify the path so that the path first check that hidden folder, suddenly you hijacked the capability to run that command. Instead of running the real ls, whenever you type ls on your terminal session, you are going to run that modified version. And sometimes that's useful. That's a useful trick, okay, to substitute a version, an upgraded version of an old command. Sometimes it's actually a problem because you can inject malicious executables like that. So in those cases, when you write / and the name of your script, there is no doubt. /myscript.sh means I want to execute the script named myscript.sh inside the current working directory. So it's 100% safe. What about the .. The .. is go back to the parent folder. So you are in /home users alessio. If I write /home/users/alessio/... then that's the same thing that /home/users. So that introduced the idea that all relative paths or even absolute paths are actually not unique. For example, if I take the absolute path /home/users /lsu/readme.txt here, I could rewrite this a ton of different ways. I could write it /home // so I go back to the root. Home again, so /home /home, which is completely redundant, but that still means the same thing, right? Then /, stay where you are, /, stay where you are, dot again, and then /home again. Why not? So I can generate an infinity of different path name for any file. So in the next slide, we are going to talk about something called the canonical path, okay? The canonical file name. That means the version that is the simplest, the shortest, that doesn't have any redundancy in it. So typically, get rid of the dot, and then the name of the folder again, or /, etc. Okay? With this, that's the minimum I need you to know to move forward and use files. Okay? So if you knew already all this, perfect. If you learned something, then I'm happy. How to abstract from these details. So there are already some details in the previous slide. What kind of separator am I using, / or /? Where is the root of my file system, etc. So instead of forcing the end user to write, actually it's not the end user, instead of forcing the programmer to write Java application that have to be updated or changed depending on whether they run on Windows or a Unix operating system, the tech of Java was write it once and run it everywhere. So that's one of the first operating systems that introduced a viable concept of portability. You write your application, you run it on Mac, you run it on Linux, you run it on Windows, it should run the same way. That means that when we program things related to files, we have abstractions in the language that allow us to not care that much about the separators. Okay, for example, just to pick on a detail. So that abstraction, the first one we are going to encounter is, there are going to be 3 of them, is the file class. The file class is actually a glorified file name. So what I mean by glorified file name, if I put between double quote /home/users/lsu/readme.txt, here we go. I have a file name represented as a string. Okay, there's not much I can do with it. It's just a file name of my file. Okay, if I create an object of class file and I feed to that constructor of that object of class file my string, now my entire file is represented by a file object. And that's going to allow me to have access to some methods, to some attributes that are going to allow me to do some basic operation on a file. Okay? It's really just a wrapper. It's a class, it's an object that's going to wrap around the string, that is the actual name of your file, and offer a few features. So what kind of features are we going to offer? And I do apologize, this is awfully small, so I'm going to try to give you the gist of it. So we have here a pseudo UML diagram of the file class, and we have a bunch of methods. So I'm not going to go and comment each of them. You have here the description, there's a little detailed description from the textbook. What I want to point out is the overall set of features that are available. First thing, at the top, 3 different constructors. So what do I use to construct an object of class file? Well, I can pass just a string. I can pass a string that represents a parent, so generally a folder name, and then a string that represents just the base name of the file inside that folder. Or I can pass an object of class file that represents the parent, and then pass as a string the name of the child inside that parent folder. So whether you are talking about, this is one source of confusion once in a while, but every semester some students are affected. When you are talking about a file object can represent what we call a file, readme.txt for example, on disk, or it can represent a folder. The same abstraction, the file object, is used to represent a folder and a file. So that's why the parent here is also represented as a file object. What comes next is a bunch of methods that are going to return Boolean and that are there to help us check pretty much the metadata about the file. Is it readable? Does it exist even? Can I read it? Can I write it? Can I don't know, is it just a file, for example, as opposed to a folder? Is it a directory as opposed to a file? And so on, so forth, okay? So what we have here is everything that's related to the metadata of the file. Then we have a way to break down that string that we originally fed to the constructor, to break it down and get, for example, the absolute path out of it. So even if I construct an object of class file by saying, you know, this object of class file is going to represent ... / user / team / readme.txt, so I use the relative path, okay? There is a way to query that object and say, convert that for me to an absolute path. And depending on whether you are on Unix or Windows, Java is going to use the correct delimiter, is going to use the correct root of the file system. That's what I meant by we are trying to abstract ourselves a little bit from the tedious details. And then there is another one here that is interesting. It's get canonical path. Get canonical path. I already mentioned to you that you could make a path name arbitrarily long, okay, by using ... then the name again of the folder, etc., and so on and so forth. So get canonical is going to give you the absolute path that is the shortest. No repetition, no kind of looping inside the path name with the ... and operators, okay? It's going to be a unique identifier pretty much for that file. Unique location identifier. Please note a little detail here. It's a detail, but it's important. When you write a string in Java that has // unique style separator, everything goes well. If you write a string in Java that has backslashes in it, then you have to be careful. So the Windows style of file naming and stuff like that, the separator, is actually not really well integrated with Java, I would say, because a backslash in a string is an escape character. So if I want to put a double quote, for example, in a string in Java, I cannot just do double quote, double quote, double quote, a double quote inside double quotes, right? I cannot do that because Java will understand that as being double quote. You open a string, oh look, another double quote, that must be closing the string. And then there is a double quote that's floating in there, this is a syntax error. So what we do is double quote, and in the middle we put backslash double quote. The backslash is an escape character. It neutralizes the meaning of the character that follows it immediately. So the way Java reads that is double quote, you're opening a string. Backslash, watch out, the next character is to not be taken with a special meaning. It's a double quote, so I'm not going to take it as it's the end of the string. I'm just going to take it as it's the character double quote that needs to be displayed. And then double quote again, this one is interpreted as the end of the string, okay? So if we want to put a backslash in a string like that in Java, we have to double it. So we write here, for example, C:\, \book, \, test dot dat, okay? And each of the backslash just means, hold on, the next character is not to be interpreted as a special character. Here comes a backslash, so it's just backslash in the path name, pretty much. So that's one little thing to be careful about. I would use, if I was you, I would use just a /. That makes things a lot easier. More metadata information here. What is the timestamp of the file? When was it last modified? What is the length? If your file object represents a folder, actually, you can explore the content of that folder by calling the method list file that is going to return to you an array of file object. And that array of file object represents every subfolder or every file that is present inside your current file object. Okay? You can delete a file like this. So you have some basic operation here, delete, rename, and then you can create and delete subfolders, assuming that your file object refers to a folder on disk. Okay? And that's pretty much everything that we have available to play with. This is going to be an example of program that we run on multiple platforms. So the top version, that's the output of our code, okay? The top version was run by the author of the textbook on DOS command prompt, okay, inside a Windows system. So terminal, I should say, actually. And then the bottom one was run also on Windows, but this time telnetting into a Linux system. So I don't know why telnet, because I don't think anybody uses telnet anymore. This is really not secure. But anyway, the bottom line is what you see executed here ran on a Linux system, or Unix system at the least, and this ran on a Windows system. And it is the same code. The thing that we have been doing here is we have been calling a bunch of those methods that we had on the previous slide and displaying what they were outputting. So a lot of it is going to be the same, okay? But some things, like for example, what is the name separator, that's going to be different from operating system to operating system. So that just illustrates how you can do what was the Java motto when it was first introduced, how you can just write once a piece of code, and here's a piece of code, and then run it unchanged, unmodified on multiple platforms. This is something that we take for granted nowadays. When you take COP2513 and you use the C programming language, you are going to see, if you try, that the C programming language is really not as portable as Java. Okay? If you go from Mac, Linux, Windows, based on what subset of the C language you use, you might be okay. If you start doing some fancy things or even just file I/O and stuff like that, your application will have to be actually rewritten to move from one platform to the other. That's what we are trying to avoid at all costs in Java. So what is the code doing? Very simple. Creating a new file object. And again, the misconception that I see occurring most of the time when I teach this is it's natural to think new file, oh, that must be where I create the file. No, it's completely independent. What you do here is you take a relative path name, image/us.gif, okay? You take a relative path name that is represented as a string, and you wrap around it a file object. But nothing happened on the file system. No file was created. No file was even checked, okay? You could wrap around with the file constructor any string, a string that say, hello there, how are you? And it would be okay. It would be compliant with that, okay? So separate was the creation of a file object with actually any actual operation being performed on the file system itself. It's only when you call methods or when you create more objects of different classes that things are going to start happening in the file system. For example, when you call file.exist, well, I need to return a Boolean true false that tell you if the file is actually there on the file system. So I need to go and look, check on the file system, right? So something has been done on the file system. File.length, I need to go read the metadata from that file and report to you what is the size of the file in bytes. Same thing for can read, can write, I need to check some metadata. Get absolute path, again, I need to check on the file system, convert the relative path that you gave me into an absolute path, okay? So only when you start calling methods like that, you have actually things happening that are related to that file. Otherwise, the file object is just a handle, like a construct that allows you to pretty much refer to a folder or a file on your disk. So, do we need more than just a file object? Yeah, definitely. If we want to perform anything that is beyond, the scope of pretty much what was on the previous slide, which was very, very limited, okay? If we want to perform anything beyond that scope, like for example, reading from the file, writing into the file, then we need to have special method for that. The file class doesn't provide us with those methods. So we are going to have to create more objects to just say, I want to actually read and write from that file object, from that file that is represented by a file object, okay? Those classes are going to be scanner, which you are already all familiar with, and print writer, which is the new one we are going to introduce, okay? So scanner and print writer, we are going to have to create an object of those class, an object of class scanner when we want to read from the file, an object of class print writer when we want to write from the file. So the minimum amount of steps, to be able to read from a file is have a string that represents the name, create a file object around the string, and then create a scanner around that file object. So it's kind of like playing Russian dolls. Everybody knows what Russian dolls, right? All right, you open them in half. The large one accommodates the second largest one. You open this one in half, it accommodates that one, it accommodates that one, and so on and so forth, okay? So at the end of the day, you can put all of those Russian dolls into the large one, and they are concentric. That's exactly what we are doing here with this approach. We have a string. A string is an object, right? It represents the file name. And then around that string, I created a file object. So more features, but not enough. Now I want to read from that file. I put a scanner around the file object. So visualize it as concentric objects that compose with one another, and every time we are adding some features. So we're not going to start with the scanner, because the scanner is very simple. We're going to start with the one that's actually new, the print writer. So let's take a look at this print writer class. So it's java.io.printWriter. So if you don't want to have to write, every time java.io.file, java.io.printWriter, etc. in your code, you're going to probably do an import java.io.file and import java.io.printWriter at the beginning of your code. If you want, you can even do an import java.io.star, and that's going to make sure to import all of the classes, including exception, that are from the IO package in Java. So what do we have inside the java io.printWriter? We have a constructor. Actually, this is not the only constructor. There is also a constructor that takes a file as parameter. I don't know why it's not mentioned here. So there is a constructor that takes a file object as parameter. That's the one we're going to use. And there is a constructor that takes a file name as a string as parameter. This is another option that's available to you. You can bypass creating yourself the file object. You can rely on the print writer pretty much to do that for you. But the problem here is that if you do that, you won't have access to the file object. So if you are trying to test if the file exists, etc., you're going to have to recreate another file object to just do that. So I recommend that you always create a file object from the string and then a print writer from the file object instead. And then what we have inside is a lot of print, a lot of overloaded version of the print method. One that prints a string, one that prints a single char, one that prints an array of char, an int, a long, a float, a double, a boolean, all of our primitive data types plus the reference data type string. All of those are covered, okay? So we have a print method, and just like what we have been doing with system.out_print, okay, we have also a println version. And the println version, they are not all written here, but it's going to be the same thing. There is one overloaded println version for each of the basic data types. And then we have a printf method. And the printf method, there is just a little interesting thing I need to show you about printf. It's not interesting from the technical point of view. I know some of you have already used printf. I didn't emphasize it in this class, and I'm not going to ask you to use it in the exam or something like that. It's just good to know that it exists. And trust me, in COP2513, you'll have plenty of time to get acquainted with the syntax of printf, because unfortunately there you are not going to be able to avoid it, okay? So printf stands for print formatted. It allows you to actually specify exactly, with a lot of options, how you want text to be displayed in the console. Left-centered, right-centered, centered, over a window of 30 characters. Even if it's bigger, you truncate, and so on and so forth. Think about everything you can do in an Excel cell, for example, in terms of truncation, wrapping around, etc. You can do here in a console with printf. The interesting thing about printf is that it's a barbaric syntax. Started in the 80s, actually earlier than that, a little earlier than that, with, you guessed it, the C programming language. C programming language introduced the printf syntax. This is what it looks like. This is not even a complicated version of printf. This is not the most gory version I could have found here. %10.2f. %f means I'm going to replace this here. It's a placeholder for a floating point number. So here's a floating point number, x. And then between the % and the f, options. Like that floating point number will be displayed on 10 characters, no more. .2, that means that out of those 10 characters, there's going to be 1 character for the decimal dot, and then 2 characters maximum for what comes after the decimal dot. So that's just precision formatting, okay, of our floating point number. I said the syntax is barbaric because it's really kind of Perl-like. If you have had the chance to play with a Perl programming language, it has a lot of syntaxes like that. It's an acquired taste, let's put it that way. Things change when we introduce C++. You see the C++ equivalent of the above here is using cout, the standard output channel. So it's using a completely different way to obtain the same stuff. It's using some methods here to set the precision, to set the window, the width actually, and to say that it's going to be a fixed precision. And then 1996, so 16 years later, this is supposed to be progress, okay? So this is Java take on exactly the same thing. That's why some people hate Java, is because they think it's overly verbose. And it's true. It's really verbose. Everything is in object-oriented programming notation, even the simple stuff, okay? So we jump from something that was like 1, 2, 3, 4, 5, 6 character to something that is actually 3 lines of code, 5 lines of code, okay? But the advantage is that we're using classes, we're using method. It's actually more readable, but it's bulky, okay? So what happens after people spend 16 years, trying to go away from a short but difficult to read notation to an easy to read notation that is bulky and verbose? They started reinventing the wheel. So in 2004, Java reintroduced the printf. Okay, so we are back to what you are going to use if you use printf in Java, what you are going to use in 3515. They are very similar. This is a good old printf. In 2008, Scala and Groovy, that are JVM language that run on the JVM, reintroduce also the printf, but this time you don't need a semicolon at the end, so that's real progress. And in 2012, that's actually not jokingly progress. We have a version of printf that is checked at compilation time. One of the things you'll discover with a C programming language in 3515 is that when you mess up those %10.2f codes, when you say, for example, I want to display a floating point, f, but what you pass is an int variable, you would think the compiler would tell you, hey, watch out. Your formatting string says that you want to format a floating point number, but you gave me an int. Mismatch of type, compilation error, etc. That would be nice. Unfortunately, that doesn't happen. That doesn't happen in C, that doesn't happen in Java, okay? It's only when you go to Scala, for example, and specific version 2.10, it's a recent thing that now the formatting string is being checked for this kind of errors by the compiler. Okay, so other than that, in C, you get the program to run and do something weird. So it's going to try to display your int as if it was actually a floating point number. So you're going to get a weird result on the screen, and you're going to think first, well, I did a mistake in my calculation. You're going to spend 10 minutes checking your calculations, and then you're going to say, well, that doesn't make sense. My calculations are okay. And finally, you will realize that it was just one letter that was off in the formatting string. All right. So I don't want to spoil the adventure for C programming, but this is what awaits you down the road there. Let's take an example. So here's an example of code that's going to, as the name implies here, write some data. So we have a main method. We have the string that represents the relative path name, the relative file name, actually, that's the whole thing, to my file. So just scores.txt. So that means, this is the same thing as /scores.txt, which means scores.txt located in my current working directory. So wherever you start running the application, this is where it's going to look for that file. And I create a file object around that string object. All right, and now that allows me to use some of the basic feature, like file.exist. If file.exist, then display the file already exists and exit the whole application. Okay, I want to write content to a new file. I don't want to overwrite. I don't want to append at the end of the file. So I'm doing this first thing, okay? And then, now that I got out of the way everything that I can do with just the file object, now I need my print writer. So I'm going to create my new java.io print writer. I'm going to pass to its constructor the file object. So it's going to wrap the file object inside a print writer. And now, this print writer that I refer to with a variable output, I'm going to use it to write pretty much some text in that file. So write a name, John T. Smith, then write a value, 90, println, go to the next line, write another name, another value. So I'm writing names of people, students, and then their grade in the class, for example. okay? And I do that as much as I need to. So everything that you learned in the last 2 semesters about working on the console, displaying things on the console, making a loop to display a bunch of things, etc., all of this applies here. Okay, this is a simple example, but it's just like redirecting everything that you learn to a different target, which is a file instead of the console. So nothing is going to show in the terminal, but things are going to be written in the file, and then output.close. We talked about that, right? You need to close your file. So watch out. The file is actually created when you create the print writer, not when you create the file object, first thing. And second thing, we talked about that close. We talked about the fact that it was good practice to close your file. Well, it's more than good practice. So let me tell you about a bug that some of you are going to encounter. And hopefully you're going to encounter it before the final, or you're going to remember this advice and you're not going to have to panic during the final, try to figure it out on your own. If you write data to a file and you never close it, when your application ends, it will close the file, but it will not close it properly. So there is a chance, and I say there is a chance because it's non-deterministic. Okay, it depends on a lot of factors that are beyond your control. There is a chance that you write a program that say, I'm going to write into a text file the number 1, 2, 3, 4, 5, each on a separate line, and then stop. And because you didn't close your file properly, when your application stops running and you actually open the text file to look at its content, what you see inside of it is nothing. So if that happens to you during the exam, during the practice exercise and stuff like that, okay, immediately suspect that you didn't close properly the file. What's happening underneath, what explains that behavior, is that when you say, I'm going to, for example, output.print John T. Smith, when your application issued that request, who is it talking to? It's talking to the operating system. It's doing what we call a system call. It's telling the operating system, you know what? I need some data to be written into this text file. And you are the only one that has access actually to the physical devices that form this computer. That's the job of the operating system, right? It's an interface between the applications that are running and the hardware. So it's managing all of your hardware. So now we are getting to the point where we want to write something. Well, it was already true when we wanted to write to the terminal, but now we want to write to the file system. So we ask politely the operating system, please write this for me. And the last thing the operating system is going to do is jump to it and actually go write the bytes that correspond to your information on the disk. Why? Because there are a bunch of processes, a bunch of applications running in parallel on your operating system, right? So if every time one of those applications said something about writing somewhere on the disk over there, if every time I was running and doing that small operation and then coming back and being like, okay, what's next? It's kind of like a puppy, you know, that you're throwing a ball and they're running right and left, coming back, etc. That's not going to be efficient. What is efficient is to say, oh, you want to write John T. Smith into that file. Let me put that in a buffer inside the operating system. Then a few milliseconds later, you tell me, I want to write the value 90. Sure, I'm going to put that into the buffer after John T. Smith. Okay? Then there is a println, so yes, I will in the future go to the next slide. And I keep storing things. And when I reach a certain size of buffer, which can be variable, okay, it's better for me to go to the file system, find your file, and write, for example, those 500 bytes of data, than to just write 2 bytes, then 3 bytes, then access again 5 bytes, then access again 10 bytes. Okay? The problem is that to make this efficient, the buffer size, it needs to be, a decent size. Okay? So the larger the buffer, the more I optimize my disk access, my performance in disk access. The problem with that is if I yank the power plug, then everything that was in the buffer in RAM goes away and it never got a chance to be returned to the disk. Same thing when you shut down an application or an operating system abruptly. You bypass the standard procedure, which is the standard procedure to shut down is to flush all the buffers. Flushing the buffers means I write their content to disk, even if I don't have enough to make it a very efficient operation. Well, here, same thing. Your app closes a file, we properly flush your buffer. Your app doesn't close the file, I don't know what happens, okay? Every semester I redo the test with the latest version of Java, and last time I did the test over the weekend, I still had an empty file, okay? So again, it's not automatically handled, even though technically the file descriptor is released to the operating system, it's not properly flushed. So yes, it is very important to actually close your files when you're done using them. Yeah?
So what if you have what if you print stuff, but you have two blocks that you're printing information that are separated by different lines of code. So should you use the output.close statement after you output?
So you would not use, I don't remember the name of the method, you would not use close because that's a costly operation, but there has to be in Java as well a flush method somewhere that allows you to say, okay, I'm not done with this file, but it's important that, I flush the content of the buffer, the IO buffer to disk, just in case something happens, okay? So that's when you would use that kind of method. But I'll have to look it up because I haven't used that in probably a decade or so, all right? Oops, went too fast. So just to help you with that, we have a syntax. You remember the try-catch block? You can add after the try keyword a set of parentheses. And inside that parentheses, you can have one or more declarations. These are declaration of reference variable that are going to refer to what we call resources, like open files, stuff like that, okay? And their initialization. So you can say try, open parentheses, I'm going to have this print writer, connected to that file. Close the parentheses. Open curly brace. Here's the code that I want to use while that print writer is active. And then close the curly brace. Here are my catch options, and that's it. And what it's going to do for you is automatically, once you are done executing the code in the try block, this code here, it's going to know that this resource needs to be closed, properly closed. So without you having to write a close statement or remember when you need to close the statement, automatically when you reach the end of this code, it's going to do it for you. And if there are exceptions, yes, it's going to also do it for you, close the file before to handle the exceptions. Okay? So it's a very convenient way to write stuff like that, for example. So this is the same thing than before. We open our file here. We test that it exists. We open our print writer, but this time I put the declaration of the print writer named output. I put it inside the try parentheses. Okay, so it's going to be available for this portion of the code, the curly brace block that follows immediately the parentheses, and I don't have to worry about closing it because when I reach the end of that curly brace block, it's going to automatically say, "Oh, you declared a print writer here. Let me close that for you." And we can have a print writer, we can have a scanner, we can have all sorts of things here. There are like more possibilities, but in this class we're just going to use print writer, scanner. This is where you would declare them and then pretty much designate the block of code in which you want to use them so that you don't have to worry about having to close them. And like I said, it's even exception proof. So can you do both? Can you do try and catch with this new syntax that adds parentheses to try? Absolutely. So here's an example. I'm going to go fast because I just want to point out the try and catch syntax, okay? But it's a little explained in the textbook. It's above what we are doing in this class. It's how to open a connection to a database, okay? But quickly, we have a SQL query here that is in a string, okay? Some of you might recognize the SQL syntax here. Then we have a try statement. Between parentheses, stmt is going to be a reference to an object of class statement, which I obtain by calling con, which is my connection to the database.create statement. So that's my resource. That's why I told you it works with scanner, it works with print writer, it works with a whole bunch of things in Java that need to be closed. Everything that needs to be closed, you can declare in the parentheses here, and it will be automatically closed. And then inside the block of code that uses that stmt statement reference, I execute my query on the database. So I'm just giving you the quick outline, okay? I'm executing my query on the database. I'm looking at the result of the query. Is there something there? If there is, I extract from the result of the query some specific fields. like for example the coffee name, the price of the coffee, the sales total, etc. Display what I want to display on the screen, and then I reach the end here of my curly brace for the while. So I keep doing that while there are some results in my query. And then finally I catch a SQL exception. So any form of SQL exception that can happen is going to be caught here and handled here with this specific method. Okay? So what's important in that slide is not the syntax of how to interface with a database. You'll have time to learn that by yourself as soon as you have an interest in interfacing with a database from Java, Python, or whatever. Okay? It's not what's important. What's important is the universality of this try, parentheses, catch, syntax, and the fact that you can do all in one. So when you are doing I/O, you can get the benefits of not having to close your file yourself. You can get the benefit of handling all the exceptions that may come out. And if you slap onto that a finally block, you are really bulletproof pretty much. Nothing can go wrong. No matter what scenario unfolds, your files are going to be properly closed. Everything is going to be taken care of. So all of this is to write to a file. Now let's talk a little bit about how to read from a file. And that one is going to be super fast and super easy. Why? Because we are using the scanner class. So we introduced the scanner class in the very first days of COP2513. We introduced it again, at the beginning of this semester. We have used it to read from the console, so pretty much read from the keyboard, okay? But reading text from the keyboard is not that different from reading text from a file or reading text even from a network connection to a web server, as you are going to be able to see if you do your reading assignment, when you do your reading assignment, okay? So the idea here is that every time you have a stream of character coming from somewhere, there ought to be like a standard way to handle it. Absolutely, this is a scanner class. So what do we find inside the scanner class? Well, constructors. So this time the constructor that takes a file object shows up in the list. Don't ask me why, but that's good because that's the one we're going to use whenever we want to do reading from a text file. We're going to create a file object around the string that has the name of the file. Then we're going to create a scanner object around that file object. Alternative that you have, you can create a scanner on something like system.in, which is pretty much a stream. We're not going to cover that in more details. But you can also create a scanner around a string. So when I told you a stream of characters, ought to be readable in the same way. If I have a string that represents, for example, an entire paragraph, or forget it, it represents a chapter of a book. One string, one giant string that is maybe, like a few hundred or thousand of kilobytes or whatever. This is my book in plain text. Well, I can read from it like if it was a file. All I have to do is tell a scanner object, I want to build a scanner. The scanner is going to read from that string. And now you're capable to use that next int, next line, etc. All those methods that we have used to interact with the console, you can use them to read from that string or read from that text file. Again, read from that internet connection. We're going to see that at the end. You have a clause, of course, and then the others, we have used most of them. The as next allow you to just check if there is something more to read in the pipeline. Generally, we have a loop that say while something dot as next, okay, keep reading, and then when as next is false, then we're done. We just read everything there was to read in that source of information. The next gives you the next token of a string. So that's a different way to present that method. I never used the word token before. So what defines a token is the delimiter. So when you create a scanner, it has some default delimiters. For example, a default scanner is going to assume that the delimiter between words is any of the spaces. So a space, a tabulation, something like that, okay? Well, this is not the only thing that you can have. You probably heard about CSV files, comma-separated value files, okay? You can save like an Excel document that has no fancy formatting as a CSV file. You can import a CSV file as an Excel document. So these are literally rows of data, okay? And each value for each column is separated by a comma, hence the name, comma-separated values. So in that case, if you were able to tell a scanner in Java, the delimiter is not space or tabulation. The delimiter is now the comma. then it would look at this line of text, and when you ask for the next token, it would not give you the next word up to the next space. It would give you the first value up to the next comma, up to the next delimiter. And then you call for the next one, it gives you the next value until the next comma. Next one, next value until the next comma. So delimiters allow us to specify a structure, and then we can read one field at a time. And again, the common use with a scanner on the console is, we just use delimiters that are like white spaces, and then that allows us to read one word at a time in a sentence. But there is more to that story. So next, and then next byte, next short, next int, long, float, double, all of those cover like the reading of primitive data type. So you have used those one. Next double, we used it a lot. Next int, we use it a lot. This is going to allow you to read just one primitive data type at a time. And then there is one more here that doesn't appear on the list. It's probably something that the author of the textbook forgot. Next line, which allows you to read an entire line of text up to, well, when it's a keyboard, it's up to whenever the user hits enter. When it's going to be from a file, it's a line of text up to whenever we reach that special marker that say this is the end of the line. And then the next character is the first character on the next line, and then there are going to be more than another special marker. So a text file is a continuous stream of characters with the special markers indicating when it's the end of one line of text and you need to go to the next line. So when you display it, for example, or when you read it with, for example, next line. Here's an example putting all of this in application. So we have, again, a string representing our file name, scores. We create a file object around it. Then we could test if the file object exists. We're not doing that here. Instead, we create a scanner around the file object. So now we are ready to read from that file. How do we do it? Again, very similar to what you have done before. So while input is the name of my scanner, input.asNext, as long as there is more stuff to read from the data source, I'm going to input.next and I put that in a first name variable. Input.next, put that in the middle initial variable. Input.next, put that on the last name. And then input.next int and store that in the score. So my file that I was writing in the previous example with the name of the student, James T. Kirk, and then a score or whatever, a grade, right? Now I'm reading that file, James, T, middle initial, Kirk, and then the score, the grade that he obtained. And then I put that in a loop, this loop here. I display every record that I read, every line that I read from the text file, and when I'm done, I close it. So is it as critical here to close the file? I don't even want to know the answer to that question, honestly, because if I start telling myself, here's a list of times where I should close the file, and here's a list of times where I can get away with not closing the file, then I'm going to be tempted to always try to get away. One day I'm going to mess it up, and I'm going to waste half an hour to 3 hours debugging a stupid piece of code, okay? So instead what I say is, every time you open a file, make sure you close it, either explicitly or with that new try parentheses syntax, okay? Or maybe in a finally block if you prefer, but make sure you always close your files all the time. It's bulletproof and it's actually clean code. All right, we have a little over 5 minutes left. I want just to show you a more realistic example, and then we're going to stop here. So the web crawling example, I'll leave it in the reading assignment. You can check it out, okay? It's a little longer, but it's interesting if you want to know how to apply that stuff to something a little bit more exciting than just plain text files. Here's what we are going to do. We are going to write a little program. So it's going to be called replace text.java. And when I'm at the command line, I want to be able to type Java replace text, which is the name of my class, and I want to pass arguments to my program. So we've never done that. I don't recall that we have done it in COP2513 or 12, okay? It's how do we turn one of our little Java program into pretty much a command line tool, something that we can invoke from the terminal and pass argument to. And how do I get those arguments, those value here, the format string.java name, the t.txt name, and so on and so forth? How do I get them inside my code? So here what I'm saying is my little tool is going to allow me to replace inside the file format string.java and output to the file t.txt, replacing every occurrence of string builder by the name string buffer. So it's the syntax is name of the command, input file, destination file that you're going to create, and what you want to change in the input file. So I want to replace this word by that word. Okay? So it's just a little command line tool, easy. How do I do this? Well, first thing I need to know is how to get access to those arguments that are given to me as a command line. Okay? So it's going to be through this array, args. So the main string square bracket args that we have never really used until now, if I remember correctly, now we're going to use it. It's an array. The first element of the array, index 0, is going to remind me of the name of the command itself. And then index 1 is going to be the first argument, the second argument, the third, and the fourth. Okay? So first thing I do in my code is I check if you gave me less than 4 arguments, you made a syntax error. So let me tell you how you use my tool. You type Java, the name of the class, and then I want the source file, the target file, the old string that needs to be replaced, and the new string by which you want to replace the old string. So if I am using the command line, I just type it like this. So this is a DOS prompt. This is a terminal, a Windows terminal, right? And I'm just typing inside the folder where I have my file. In this case, it's called something.java. Okay? I'm going to type Java, the name of the class, and then all my argument afterward. It's just like I did in the previous slide. What about JGrasp? If you want to run some programs like that in JGrasp and pass some argument to them, you are going to have to enable that little window here that's called run argument. To enable that window, you go to the build menu, you go to run argument, you check that box here, and then this little panel is going to show above the file that you're currently editing. What you type in that panel is separated by spaces. All of the argument you want to pass to your application when you run it. How do you run it? Same old, running man button or the bug button if you want to run in debug mode. Okay, so this has not changed. But now we have the option to specify here what argument have to be passed, and you don't have to retype them all the time. Once you type them, they stay there until you erase them or you replace them by something else. So we took care of that. We took care of how to run our code and pass some argument to the application. We know how we are going to get those arguments inside the application. It's that args parameter for the main method. Now, what are we going to do with the arguments? Well, we know that in arg0, we are going to have actually the name of the source file. So I'm going to say file source file equal new file, and this is a string that represents the source file. Then I'm going to check if it exists. If it does not exist, there's nothing for me to read from. So I display an error message, and I system.exit2. So system.exit with a code 2, that means I was not able to find the source file. How do I know that 2 means I was not able to find the source file? I don't. I made that up. You are the person writing this application, right? So when I use your application, part of the documentation you are going to give me is you are going to give me a documentation that say, when my application is not able to find the source file to read from, it exits with a code of 2. And you chose that code completely arbitrarily. Okay? So same thing here. I look at the destination file. Okay? So I create a file object around the string that represents the destination file. And I do the same kind of test, but this time I want to make sure that this file does not exist. I'm going to write it. So if there is something, I don't want to overwrite accidentally something that's important. I don't want to append at the end. So I'm going to say if the target file exists. So here I was testing if it doesn't exist, error. If it exists, then error and exit free. Again, why free? It's totally arbitrary, but it's going to be documented. Everybody who uses my program will know what to expect. Why didn't we actually check that the file exists every time when we create the file object? Again, this is because creating the file object has nothing to do with what's happening on the file system itself. Okay? So I create the file object. Maybe the name that I'm using is the name of a file I haven't yet created. It's going to come into existence when I create my print writer, right? So there is no way for me to tell beforehand what's going to happen with that file. And then the core iteration of our program and what we're going to end with is this try block. So I use the try parenthesis syntax. This time I'm going to say, here we are. I need a scanner named input wrapped around the source file object. I need a print writer named output wrapped around the target file object. So I need more than one resource. That's okay. So what you put in the parentheses here is always declaration of reference variable followed by their initialization. And those reference variable have to refer to a class of object that's called closable in Java. Things that can be closed and that need to be closed properly. Okay? And then I put my code. While the input has more stuff to read a line, an entire line from the input, and then use the replace method from the string class, replace all, to replace every occurrence of the second argument that you gave me on the command line by the third. Okay, so this is replace that word by that word. And then once I'm done replacing inside that string that I just read, then I write the resulting string inside the file referred to by by output. So my target destination file. And then that's it. No need for closing because I use that try parenthesis syntax, and we are good to run this and have it copy the content of one file into another, replacing on the fly occurrences of one word by another. All right, and this is where we're going to stop, not only for Module 4, but we've reached pretty much the end of lecture for this semester. So what we have left on the table, so first, if you are curious, do take a look to the web crawler example, just for fun and not giggles. And I'm going to leave that also in the PDF, okay? But it's kind of optional. I'm not going to ask you to do this kind of stuff for the final. But if you have questions, just post on Piazza. And then next step for us is answer that survey so that I know how you want to proceed. Have a good Thanksgiving. Recharge those batteries. You need to breathe a little bit before the final push, okay? And next week, we'll see each other one way or the other, and we will work on getting you ready for that final exam. All right. Thank you, guys.